Hi, everyone, and thank you for joining me for today's episode in Caserta's Data Intelligence webinar series. I'm your host, Remy Rosenbaum. And today we're going to explore the topic of alternative and external data sources for high-value business decisions. You know, when I used to hear about discussions around alternative data, it was always in the context of using it as a tool for discretionary investors and fund managers to outperform the market and generate alpha. But the use cases and impact of alternative and external data sources are no longer confined to financial services. There are cases in healthcare and even a domestic beverage manufacturer that was using alternative data in order to better forecast goods sold and reduce costs of overstocked inventory. In the insurance industry, for example, alternative data is revolutionizing risk analysis and assessment. And in every industry, alternative data is quickly becoming an integral part of understanding the larger data story in every industry. And to give us a better perspective on that, today we have two excellent presenters that are going to shed some light on leveraging alternative and external data. And first up, we have the father of Infonomics and Caserta's principal data analytics strategy, Doug Laney. Mr. Laney is a best-selling author and recognized authority on data and analytics strategy. He advises senior IT, business, and data leaders on data monetization and valuation, data management and governance, alternative data, analytics best practices, and information innovation. And after that, we're going to do a little dive into the technical side of things with our very own sales engineer, Brent Walker, who will talk about using alternative data and its many challenges. He'll then delve into the solutions involved with them. He's worked with clients across a broad range of regulated industries, from financial services to healthcare and research. And he has a particular interest in leveraging data and technology to address compliance and risk management challenges. So first, just a bit of housekeeping, and then we'll get started. Caserta is a strategic firm, a consulting firm focused exclusively on data analytics. We help business and IT leaders like you transform your organizations by and through your data. We provide strategic consulting with detailed roadmaps, architectural design, and advanced implementations of all of our recommendations. Our expert consultants are force multipliers that partner with you and your team to achieve your business outcomes and future-proof your business. Like you know, our webinars are always complimentary, and they're really designed to give you insight into today's hottest technological trends and issues. And after today's webinar, I really encourage you to speak with us about any questions you have on how to apply what you've learned today at your organization. Our initial consultations are always free, and if we find an opportunity to work together, then we can discuss next steps. And if not, we will gladly point you in the right direction. After today's webinar, I'll send you a recording to the email address you provided so you can see it at your own leisure. And if you have any questions throughout the presentation, please enter them in the questions panel on the right, and we'll answer them during the live Q&A session at the end of the webinar. Doug, the stage is all yours.
Thanks, Remy, and good afternoon, everyone from Chicago. First off, let's talk about the data economy and the perception that organizations have about data that exists inside and outside the organization. There's a bit of a dichotomy here in that many businesses are not directly monetizing their information assets, and by directly monetizing, we mean exposing them more externally, sharing them with others, even licensing them. And the focus has been very, very much internal and not outwardly focused. And at the same time, most executives believe that the value of their information assets is actually on the balance sheet, but it's not. Current accounting practices don't allow companies, even data companies, to recognize the value of their data on the balance sheet. So this creates a situation where organizations perhaps aren't leveraging data as well as they could because it's not considered an actual asset according to the accounting standards. So let's focus a little bit more right now on the actual data sources. And when we're thinking about data sources that we can use in the enterprise, we're often thinking about our enterprise data, our operational data that we can use that we generate during the normal course of business. But and when we talk about big data, we're often thinking about the big data lakes or data warehouses that we're building internally, where in fact the largest source of data may actually be outside the organization. So particularly today, and Remy gave a few examples, and I'll share a few more, a lot of the high value use cases for data for analytic purposes and automation and AI come from data that is outside the organization. And so let's explore these briefly, and then I'll give kind of an example of each. So first, of course, we have the enterprise data, the operational data. Then we may have dark data that was used for a single purpose and kind of forgotten about, like emails or documents. And then externally, There's open data published by government organizations and others worldwide. There's data you can exchange or get from partners or suppliers or customers even. There's syndicated data available from typically from data brokers and available on data marketplaces. There's data you can harvest or license from social media vendors, and in the center there's web data. Many organizations don't realize that there are technologies out there that can harvest web data and put it into a structured form that can be used. But really the particular advantage of all of this data is when it's integrated. And my colleague Brent will talk a little bit more about the challenges and opportunities of integrating all of this data in a little bit. But let's dive in and look at kind of each of these and share some examples. Now, over the years, we've compiled nearly 500 real-world examples of how data and analytics are being used by organizations in almost every industry and every corner of the world. I'm not going to share all 500 right now, but we use these examples to help inspire clients and get them thinking a little bit more broadly about the art of the possible. We do that primarily during our series of data monetization workshops or information innovation workshops that we facilitate for clients. But jump in, one of the primary ways to generate value from data, of course, is through analytics. Unfortunately, a lot of companies are still very fixated on hindsight-oriented analytics and not enough on the more of the foresight-oriented analytics, answering questions about why something happened or what's going to happen or how you can make something happen. And so one of the ways to generate value from data, whether it's internal or external data, is to move away from just building pretty pie charts and do more advanced analytics. Of course, the technologies become much more sophisticated, as Brent will talk about, but and the skills become much more challenging to find and hire as well. But what we find is that the value proposition for moving up this continuum is really quite worth it. So it's not that you shouldn't do hindsight-oriented reporting. There's always going to be a need for that to do compliance reporting or financial reporting. But the real value proposition in most of these examples that we've compiled comes from the right side of this spectrum. All right, so let's jump in. Let's talk about enterprise data for a moment. And this again is data about your customers and suppliers or partners, or all the operational data that you generate or compile during the normal course of business. A lot of this will come from existing ERP or CRM packages or applications that you've built to manage aspects of the supply chain and so forth. So let me share a particular example of each of these. The telco called XO, and they wanted to identify churn prospects and take steps to prevent it. So they analyzed 500 discrete data elements, including support call patterns or late or delinquent payments and other ongoing vital signs. This helped them identify at-risk customers, and they've created a tailored educational program that addresses known sources of customer concern at an early stage before they morph into full-blown dissatisfaction. This solution helped them. It was a 4-month implementation, and it resulted in nearly a 50% reduction in customer churn and helped them protect tens of millions of dollars of revenue. It improved overall customer satisfaction and goodwill, and based on this solution, predictive analytics is spread organically to other parts of the company, including things like collections. So that's an example of using more or less internal data. The next one here is from an insurance company called Infinity Insurance. And they realized they were sitting on a gold mine of what we call dark data or underutilized data, or data that was used for a single purpose and kind of forgotten about. So in this case, it was their adjuster reports. And so when somebody submits a claim, when a client submits a claim, the claim is assessed by an adjuster, and the adjuster report is used to determine the payout. Now, what they did was realize that they could text mine these reports to identify the kinds of language that was used or omissions or phrases that were indicative of fraud. And when they analyzed their claims and trained the system, they identified tens of millions of dollars of previously paid out fraudulent claims that they were able to then subrogate. And it improved their success rate in pursuing fraudulent claims from only 50% to nearly 90%, and reduced the overall claims and investigation time by a full 95%. The other thing that they did here was they took this model and they baked it into their claims processing system. So now up front, they're able to identify potentially fraudulent claims with a high success rate. So a great example of using dark data, or data that was originally used for a single purpose and kind of forgotten about. Then there's open data. So open data is data that is typically published by government organizations or other NGOs. It's been estimated that there are 10 million data sets worldwide published by national and local governments and other organizations like the WHO. So some examples, and many of these data sources are typically about economy or labor or population data, things like that can really help an organization kind of triangulate on what's happening from a global economic perspective and how that translates into their own operations and sales and supply and demand models. So Belk here is a retail, and they wanted to increase the number of multi-channel customers and optimize the assortment plans and optimize store format and determine, make better decisions about opening and closing stores. So they blended and analyzed millions of customers' data across 13 different databases, and they integrated with census and ethnicity and population migration data. They developed attrition models to scorecard customers by spend level and purchase history, and help them target high-value multi-channel customers. From a merchandising standpoint, they improved marketing and real estate, using insights to localize the merchandising mix and target like customers and optimize the store network. So the results were that they almost doubled the number of customers shopping both online and in-store. And this targeted marketing led to an increase in diverse and non-diverse spend, which is exactly what they were looking for. So you can see how they integrated external data, not just using it alone, but integrating it with their own data. Here's an example of web scraping harvesting web data. So what we're talking about here is scraping data or harvesting data from websites, and it's increasingly common to track the competitors' activities or partners' activities to identify when partners might be distressed, to identify new hires, or really anything publicly that the company is putting out there. So there's like I said, there are technologies for doing this, and Caserta works with a number of these vendors to help scrape data from websites like Import.io. So let me give an example here. So Millport Sigma is a biotech company, and they wanted to price products relative to a dynamic competitive marketplace. So they collected, aggregated, and structured competitor product pricing data in real time using Import.io web data collection agents, and the data is then fed into an SAP data warehouse. This gave them the ability to continually optimize the price of nearly 200,000 products and reduce the time and expense of manually gathering competitor pricing information so that they could be dynamically responsive. Let's talk about social media data for a bit. So, obviously we participate on social media and we use it for personal purposes, but there's a great market for using this data in a commercial context. So a lot of the content from Twitter and Facebook and Instagram and others, including blog and review sites, a lot of it is available. Some of it's not so available, like LinkedIn, for example, now owned by Microsoft, puts some restrictions on your ability to harvest that data. Of course, you can purchase it from them. The types of data tends to focus more on customer sentiment and trends and relationships and brand awareness. So that's typically the data is more used for marketing and sales activities than really anything. There are a number of social media monitoring and analytics vendors out there, so you don't have to harvest the data yourself. You can work with them. So let me share a fun example. At the University of Rochester, some researchers wanted to determine which restaurants in New York City are prone to serving up foodborne illnesses. So the researchers analyzed and tracked millions and millions of tweets from nearly 100,000 users tweeting on or while they're at one of 20,000 New York City area restaurants. And their machine learning algorithm called Nemesis, if you get that joke, you're smarter than me, then followed these users for 72 hours and looked for mentions of terms related to nausea. So what happened was over 4 months, the system spotted 500 reports of possible food poisoning, which correlated with the poor health department scores for these restaurants. So going forward, the New York City Health Department is considering using this system to more proactively investigate restaurants rather than doing so in more of a random fashion, which obviously can save a lot of costs and lives as well. So then there's partner data. So this is data, second-party data available from your suppliers or resellers or partners or even customers that you will tend to negotiate for. Sometimes you'll buy it, sometimes you'll trade it for some kind of good and service. I talk about that in the monetization webinar that we gave a few months ago. So this data typically is about sales data, or forecasts, or other kinds of data that your partners captured that's related to your business, but that you don't necessarily have organic access to. So one of the challenges has been many companies already give away this data. So when I speak to grocers, for example, they say, well, we're already giving away our inventory and our sales data to our CPG suppliers just to form better relationships. And well, that's a great idea. Perhaps you can think about ways to package that data in new ways or analyze it or provide a benchmarking service to create some kind of premium offering. So by way of example, in Australia, the Australian Competition and Consumer Commission flagged fake reviews as a priority issue for the country. And so what they got Amex and TripAdvisor together to rate or rank recommendations higher for those reviews that have been substantiated or don't smack of being fraudulent. And this has helped them improve the value of hotel and airline ratings and discourage fake reviews. It's improved consumer confidence in TripAdvisor and Amex and improved the overall customer experience with travel service providers like hotels and airlines as well. And then finally, we have syndicated data. And syndicated data is data that's available from data brokers or data aggregators. So this is their main business model, is providing data. We're talking about folks like Nielsen or Dun & Bradstreet or Equifax or Experian or even S&P and others that collect and compile data, use it for their own purposes, but sometimes also make it available as data feeds or for scoring internally and other use cases. Very often it involves data that is about consumers and individuals and businesses, financial data, weather data, market intelligence, and so forth. And there are an estimated nearly 5,000 companies out there that are aggregators or brokers of data. So it's really hard to navigate this field, and I'll talk about that in a bit. So by way of example, let's talk about ADS, Advanced Drainage Supply. They wanted to improve forecast accuracy and sales revenue by identifying external leading drivers. So they compiled 5 years of sales and volume by product and region and used an economic intelligence platform available from Previdere to create predictive models and rolling financial forecasts. This enabled them to create nearly 100 predictive models within and improve their forecast accuracy from nearly 77% to 98% accuracy, which in terms of really dollar value is significant. It gave them a 26% year-over-year increase in monthly sales since its implementation. So just a few of the nearly 500 examples that we've compiled. If you're interested in hearing some more or learning about others, definitely feel free to reach out to us. Now, one of the challenges with external data in particular, and even internal data for as well, is what data is out there? What data do you have? What data is available externally? Which is most relevant and potentially highest value? It seems odd to me that most companies have a business function for procuring, office supplies, but don't have a function for procuring data supplies. And in today's, data economy or information age, it seems kind of weird. Again, we go back to the situation that data is not a balance sheet asset, so we don't think about it the same way perhaps that we do as office supplies. But consider for a moment which one is actually more valuable to the organization. So our recommendation is to hire or or contract somebody to become a data curator for the organization who can help identify data sources, determine their potential value, determine how they can be integrated and leveraged. And I think it's a really important role. They talk about the data scientist being the sexiest job of the 21st century. Well, this may not be so sexy, but it certainly is a really high value role. Talking about high value data characteristics, as you're evaluating data sources, obviously you want to start with data that originates with your organization. This is typically the highest value data that you have. You have some claim of its provenance and control. Data that's proprietary nature, others that don't have it, that would be data that was typically more valuable than other. Data that's of a general or accepted context rather than information that is not meaningful outside your organization or industry. You want to gravitate toward data sources that are secure. If they're easily accessed or hacked, this can result in a black market which may cannibalize your own efforts. You want data that's not restricted, in the way that you're able to collect it or deploy it. You want it to be sufficiently accurate, and complete, and precise for the intended purposes. You also want data, of course, that's, like I said, complete. It represents at least a solid slice of the known universe of activities or entities for which any given record is complete. You want to be concerned about missing fields as well. And also, you want it to be available for the foreseeable future. So if you're thinking about external data sources, you want to make sure that that data aggregator or data provider is going to be in business for some kind of duration, or at least that alternatives for that data are known and available. There's also a way to value data in much more financial or foundational ways, and we've developed a set of models for how to quantify data's value that are being used by a number of organizations to help them drive certain kinds of behaviors, including identifying which data they should sell or market to others, and as they're looking at alternative data sources, which data sources are potentially the most valuable for the organization. So I'm not going to get into detail on the valuation models here. If you're interested in more, definitely reach out to us and we'll walk you through them in more detail. But there are different ways to price data financially, and there's different ways to assess data's value from a non-financial standpoint based on its quality characteristics, its relevancy, and its impact on business KPIs. So happy to speak to anyone about that if you like. So overall, my recommendations are, implement a data procurement function, a data curator of some capacity, maybe even an entire group to do so if you're very serious about external data. Make sure that you identify the range of internal and external data sources that are valuable to the organization. Don't just put on your and only consider data that you're creating or that's available from partners, but look as broadly as you can. And then explore the variety of potential use cases. You'll actually find that as you start integrating data from external data sources with your own, new use cases will evolve, and you'll find ever new ways to monetize your data. There are a number of data source providers out there, and so definitely develop relationships and negotiate with them and keep alternative sources of alternative data in mind in case one tends to be discontinued. And then to ensure that you're focusing in on the right data, measure or at least estimate the cost and value add of procuring the data and integrating it as well. If you're interested in a little bit more on data analytics strategy or this concept of infonomics and how to monetize, manage, and measure information as an actual asset, you can reach out to us, grab a copy of the book. We've also recently published a white paper on the role of the CDO that you can access on our website here. But for now, I'm going to turn it over to my colleague Brent, who's going to take you through some of the more architectural and technical aspects of integrating alternative and external data. Brent,
all right.
take it away.
Thank you, Doug. That was very insightful. And I think we all do need to be a little more info savvy. And now we are going to turn it over to Brent, who's going to take us into the more technical aspects. And give me just one moment on my side. All right. Brent, take it away.
Hey, good afternoon, everyone. Just bear with me for a moment and I'll get the presentation kicked off. Okay, so I'm Brent Walter. I'm a sales engineer with Caserta. My areas of interest, as Remy have said, is largely working with highly regulated industries. I'm a certified Google data engineer. And this afternoon, I'm going to be talking through some of the challenges around handling alternative data. What makes alternative data different to the kind of data that you might be handling day to day? And then I'm going to walk you through a case study and a reference architecture for how we might think about setting up an environment to leverage alternative data. So I'll start out with a challenge, and that is that alternative data is different. Now, alternative data is different because what tends to happen is that we spend a lot more time integrating new sources, right? So there's always demand that's coming from our primary users, which are the data scientists and the business decision makers, wanting to bring new data sources in. And that can be a real challenge for traditional IT departments who are used to a much more formal way of sourcing data and bringing the data in. I'm just going to add as well that when I'm talking about alternative data, I'm probably going to be a little more bullish than Doug, the previous presenter. And the reason for that is that the case study that I'll be talking about comes from the financial services industry, really where time is of the essence. And I'll get to talking about that in a little bit more. The other thing that makes alternative data different is the variety of vendors, both if you consider open sources as vendors, but also if you consider closed sources and proprietary sources of data. And the vendors of data tend to be of all shapes and sizes. And with that comes various challenges. For example, they all have various degrees of reliability. And Doug spoke about that at some length, and some of the diligence that if you're bringing this data as production data into your environment that you might want to consider. And indeed, that impacts the integrity of the data that you might be getting from the source. And a really good example of this would be data that's arriving late into your environment when you're expecting to get it, or data where the format of the data and the schema that's applied to the data is varying all the time. Which of course leads into the fact that we have a variety of formats and systems that we might be harvesting data from. So the data might be coming in a stream, the data might be coming in batch, it might be data that we've got to go out and pull, so we've got to write some code to go out and pull from some APIs. And the final thing is that it can be tricky to combine with internal data sources. And the reason for that is fairly obvious. It's that the data is going to be at a different grain, it's not going to have any natural keys across your enterprise data, and just in general, it's not going to be as clean as your enterprise data. But the really big challenge with alternative data is that time is of the essence. Alternative data tends to have a much shorter half-life. And what I mean by that is that the competitive advantage of having a piece of data is shorter in the alternative data world. And the reason for that is that the value of individual sources are difficult to determine at the time that you're sourcing them. That makes them difficult to prioritize, which means that you tend to they don't tend to fit into sort of a traditional IT framework for thinking about integrating data. But the primary reason that time is of the essence is that competitors can get access to the same data if it's not proprietary, and competitors can get access to better data, and new data is coming out all of the time because this is a really hot topic, particularly in the financial services area. And so that's what sort of gives alternative data a short half-life. And as a result, we really need to approach approach designing systems for alternative data from a different perspective to the ones that we might do for enterprise data. So now I'm going to walk you through a success story, and I'm going to walk you through just part of the solution, and then I'm going to talk about a whole solution in a much more generic sense. So the success story that I'm going to talk about here is where we worked with a client to build up a system that allowed them to integrate brand new data sources from wherever within an SLA of around an hour. we're talking about a global hedge fund, so we're talking about a business with some size, and also some fairly strict requirements around data security and around getting data through the pipeline as quickly as possible. The way that we solved this particular problem was to empower analysts with primarily the way that we solved this problem was to empower analysts with tools to interact with structured and unstructured data, as well as putting in some systemic fixes to the key integration problem that I'm going to reveal in a moment. The other thing that we did was that we utilized a cloud architecture, and by doing that, we were able to give this particular hedge fund a platform and the ability to be able to test and deploy their models in a fairly seamless way, so into the same environment that the data was coming in and was existed. So the way that we got to that, the way that we get to our solution is through a fairly simple insight, and that is that the legacy process that we've got for bringing data into organizations traditionally is that we'll go out and we'll identify a new data source. So usually that'll be a request that comes in to the IT function. The IT function will say, well, hold on a minute, it's not that simple. Let's go and gather some requirements. Let's figure out how you're going to use the data. Then we'll go through a process of integrating the data into some sort of model, and then presenting it up through usually through a relational database, and then finally we get to a stage where business will start exploring and experimenting with the data, only to discover, whoops, key elements of the data have been left out because the requirements phase made assumptions, or at least the requirements phase forced users to make some very discrete decisions about how they were going to use the data before they've managed to get in and explore it. And so this tends to be a really slow process. Users of the data will then want to request changes, and we just get into a cycle where IT process really gets in the way, and it takes far too long to get to the innovation, which is what's so important in the use of alternative data. So what we need to recognize is that innovation first is the priority, that there are parallel processes that can run in parallel. And we also need to recognize that that identifying the source and bringing the source into the environment are business concerns. They're not just IT concerns. And so what we need to do is identify opportunities to automate simple processes, like new data comes in, there's a new data source, we want to land it into some ungoverned but still accessible area, or some area of our data environment that can be accessed by and used by data scientists, so that they can get into the explore and experiment phase, where they can get as far as developing new products and models, deploying it, and then really waiting for the IT process to catch up, where the IT process might bring the data into a governance strategy, and then look at how the data can be integrated into the broader environment. But that can happen separate to the development, if you like, of the data product, so the predictive model or the feed of data that might be useful to particular users in the organization. So from that, we get to, we're going to build up a set of principles around how we handle, or at least how we think architecturally around alternative data. And we'll start with a set of priorities, and that is that our environment needs to be agile. So we need to focus on agility. We need to focus on simplicity. We don't want an environment that's going to be a nightmare for IT to govern, or for IT to maintain, or indeed for the business to navigate. And the way that we kind of drive that is by putting self-service front and center. And by self-service here, I don't simply mean, going to a data catalog and knowing where the data is. I mean, really nuts and bolts, right? So users should have an ability to be able to source data into the environment and trigger the kinds of processes that are necessary for getting that data integrated into the environment. Authorized users, of course, right? So there needs to be some data literacy. There needs to be some education around the limitations of using data in particular contexts. But nevertheless, we really need to focus on empowering our users through self-service. So the way that the 1 hour integration system works is roughly shown in this diagram. So a new source comes in, that new source might come in on an SFTP feed, or it might come in directly into our cloud environment, so into an S3 bucket. Either way, on an SFTP, there's a sync job that will push that data into a landing zone in another set of very structured, managed S3 buckets. If it lands in S3 on its own, so you might have a public-facing bucket or a bucket where you've given a credential to a vendor to just upload data. Once data lands in that environment, we're able to pick up an event and start triggering a process of bringing the data into a more formalized environment. So there we'll push the data through some basic processes. And these basic processes are that we'll take the data the way, however it looks. So we'll pick up that it might be a CSV or a JSON file or whatever it might be, and then we'll convert that file into a format that's generally usable across the data science environment. And so here we're talking about things like Parquet or Avro, where we're able to have some schema information about the file. And from there, as our process catches up, we can develop models off of that data and publish those out to the various parts of the environment. So the solution that I've got on the screen here was a very AWS heavy solution where the data came in, we gave the users access to the data in an organized data lake. Portions of that lake were also modeled and brought through into Redshift. Other parts of the lake may have just been brought through as is into Redshift, but we really sort of focused on giving the data scientists access to the data in the form that was going to be best for the tools that they were using. In this case, it was a very Databricks, PySpark type environment. So now I'm going to get on to talking fairly quickly about a more general reference architecture for handling alternative data. And this particular solution is a solution built for the cloud. What I'm going to show you is more or less vendor neutral. It's based on a set of robust patterns that are common to a lot of the work that we do in ETL, a lot of the work that we do in building data environments, but at the same time, it has some characteristics that are very particular to the alternative data use case. And finally, the reference architecture focuses on leveraging the best of cloud, in particular using cloud native databases. And I'll give you some examples as we go through that. And this part of the presentation, I'm going to try and get us through in about 10 minutes or so. So jumping back to the principles that I spoke of a little bit before. So we've talked about agility, we've talked about simplicity, and we've talked about the need for self-service. So this particular architecture is designed to handle many sources that might be real-time or batch, and that might be coming internally or externally. Because one of the sources of, one of the more interesting sources of alternative data is, as Doug Laney pointed out in his presentation, dark data, so data that exists in your organization that you tend to forget about. So things like emails, which are not a common thing that a lot of organizations are spending much time on when doing analytics. And finally, I'll talk a little bit about the scale of the system. So here, the system that we're proposing is capable of handling big to massive data. So here we scale out beyond terabytes to petabytes potentially, but the same architecture actually slims down quite nicely. And one of the most interesting insights of leveraging cloud technologies is that many of the technologies scale down to much smaller problems and much smaller environments really, really nicely. So don't get too hung up on the fact that this is a solution that's primarily designed for handling big data. So I'm going to walk through the architecture fairly much component by component. So firstly, we'll talk through. So firstly, we'll deal with sort of traditional your relational sources that might already exist in your organization, and there. The pattern that we typically deploy is something like we'll do a big dump from the database, we'll get files out, we'll ingest, we'll push that into an SFTP environment, we'll land that, and then we'll land that so that it's ready for processing. We do much the same thing with services and API type alternative data sources. So there we'll have some jobs that will run. The jobs might be running continuously, or they might be running on schedule. They will extract the data from the service, and they'll just land those into a landing storage area. After that, we'll pick the data up and we'll do some very light processing to it. And this is to get it into the conform format that I talked about before. Typically, we'd recommend a Parquet or an Avro format, but your mileage may vary, and your tool set is really going to define what goes on in the lake. Now, a quick word about using cloud storage as sort of the foundation for your lake. Naming is really, really important. And adopting robust name conventions is what's going to protect your lake from becoming a data swamp. The other reason that naming is really important is for performance reasons, and that is that a lot of the work that you'll do in a big data system relies on identifying individual objects, and those individual objects are often found through a set of globbing operations or wildcard operations over the names of the file objects. So it's really important that that the names be structured such that the minimum number of files or the minimum number of objects is identified at any point in time in order to ingest them. The solution also is also capable of handling what I'll call high throughput streaming data. So here, this is data where the volume of data that's coming through means that it's not really economical to handle it through something like AWS Lambda functions or Google Cloud functions. There might just be too many events, and it might be worth leasing the compute time that's necessary to ingest those streams. Now, just for those of you that are on the call that may not have experienced streaming data before, what separates streaming data from batch data is that streaming data doesn't have an end, or at least conceptually doesn't have an end. And so we have to shift ourselves into a mindset where we think about, okay, what's the sample of data that I'm looking at any point in time, and how do I get more data into that? Did that data arrive late? There's a whole range of really interesting problems that crop up in streaming that you don't see in batch. But the most basic way to think about it is probably to think about it in terms of micro batches. So I'm going to take a sample from 9 a.m. to 12 p.m. and then I'm going to go from 10 a.m. through to 1 p.m. or patterns similar to that. Usually when we're handling streaming data, we're going to want to take a local copy of it. And there are two ways that we'll tend to take a local copy. And this will really depend on the nature of the source that we're handling. So if it's a source where we're pretty sure that we can apply a transform to it and that it's useful, and that every hour or so we're going to output a file that looks in a particular way and store that in the lake, that's great. But sometimes you're going to have sources where being able to replay the source from the beginning is really important, and that's where distributed log type solutions come into play. And these are things like Apache Kafka, Flink, Google Cloud PubSub. All of these kind of services are what we'd sort of use to take a copy of the stream, so then we can replay it and interact with the stream in more or less the same way as we may have ingested it in the first place. Finally, if we've got low throughput streaming data, we might just handle that with lambdas rather than going through the expense of a full streaming setup. And so a low throughput streaming event might be something where you subscribe to an event. That event might happen a couple of hundred times a day, but fundamentally it's not something that's happening every second or at sub-second intervals. And there we might, we typically take that data off and sort of pass it along into a message queue or a distributed log before we go through an ingest period. After we've got data into our lake, then we sort of trigger our more traditional ETL processes of modeling where it's necessary, and then we'll usually push that data out into a cloud-native database. And a cloud-native database here would be something like BigQuery or something like Snowflake. What differentiates a cloud-native database is that a cloud-native database separates compute from storage and allows you to pay and scale for both of those variables independently, which gives them a really nice sort of cost profile. The other application that we might have for streaming data that comes in is that we might want to pass it through and just sort of feed it on to end users. And so here we deliver the data up as a feed for other applications, possibly a trading system, might be a ticker system that's going across the bottom of somebody's screen or something like that. But we'd construct a Lambda architecture there that would pick up each event and just sort of flag it through to the downstream systems. Finally, we'll talk about how the data gets accessed. So our traditional forms of access, like dashboards, we're going to tap into the cloud-native database. For data science workflows, we're going to go one of two ways. We're either going to access the cloud-native database, or we're going to fire up an ephemeral Spark type situation. So it'd be something like Databricks or like Dataproc on GCP, and there we might want to go and access either our distributed log sources directly and perform streaming analytics directly on the systems as they're updating, or alternatively back into our lake sources where we've got really high fidelity copies of what came in from the source. And then finally, the outputs of data science, which we'd find in the form of predictive models, AI and ML type activities that are then consumed by decision support systems. So I just want to say a few quick words on security in the cloud, and that is that there are some differences between providers. Who you choose is really going to depend on the specific risks to your organization. So some organizations are going to need to do things like demonstrate chain of custody, or are going to be really reliant on public-facing services, and there some clouds are better than others, or at least the path to securing those clouds is easier than others. So it will depend on your specific risks. It will depend on whether you're using services. It will also depend largely on your existing skills. And that shouldn't be seen as a barrier, but you need to be mindful of how much training or how many additional resources you're going to need to take on. And always keep in mind that security needs to extend itself to data that you're given, data that you create, but also your intellectual property. This is one area of security on the cloud that often gets overlooked, particularly in data science communities. There's a real need to secure the intellectual property in the kind of outputs, or that are produced in the kind of outputs of a data science process. Too often, those kind of assets tend to find their way onto GitHub or similar services, and they're really not governed and secured in the way that those assets should be. They should be treated the same way that you'd handle data itself. So finally, I'm going to leave you with just a few parting recommendations, and that is that, and this is the big one. This is the same for any project if you're starting out here. It all starts with planning. Ideate with the business. Estimate the value of the work that you're going to do. Set clear goals. Define the deliverables. Align the team. Create a schedule that's realistic and that sets expectations. assess the risk to the project. So take into consideration that your external data may not be coming from a particularly reliable source, that it might disappear one day. Communicate the plan internally, measure success, and measure success. And that's it for my part of the presentation. Feel free to get in touch by email or via our website. And Remy, I'll hand it back to you.
All right, thank you, Brent. That was excellent. And now we're going to open the floor to Q&A. So there is a questions panel on the right, and please enter your questions in there, and we will answer them right now. So let's get started with our first question. Brent, this is actually for you, this one. Back on your process slide, you talked about bringing the source under governance. What does that look like exactly?
Yeah, thanks, Remy. So typically what we'd see organizations do in these kind of situations is to evolve what we call a data promotion process. So that is that you will provide an area for analysts, or at least for qualified users, to bring new data into the environment. That data will exist outside of the standard governance processes, though it will be acknowledged by the standard governance processes. So the governance process will essentially say that bit of data there is useful, is being used in the organization, but carries the following caveats, so that everybody knows what the rules around using that data are. And then over time, or at least at the correct point in the data management life cycle, when we've decided that the data is valuable, we'll bring that data under control. So we'll go through a process of advising users that, hey, the data is now being brought in, the caveats around the use of the data have changed. It's really a communication process.
All right, excellent, thank you. And this one is for Doug. Doug, of the 7 data sources that you shared, which ones do you feel are the most valuable?
I don't know. I was like, say, which of the organs in your body is the most important? Let's see. Like I said, I think that they're much more valuable when they're integrated. When we look across the range of examples that we've compiled, obviously the first one is data that's more proprietary to you, the internal data. But if you're thinking about external data sources, I think it's those that are more cleverly identified. Like web content is one. You know, there aren't a lot of sources, commercial sources of web content, so you've got to kind of go out and harvest it yourself. And then I think entering into more proprietary relationships with partners or suppliers is really valuable as well. So I don't think there's one answer to that. It depends on the use case, but generally it's data that's much more proprietary and not available to your competitors, or data that you can innovate around harvesting or collecting. That's the most valuable. Good question, though.
Okay, and this one is back for Brent. When you talked about cloud architecture security considerations, which cloud would you recommend using the most for insurance industry?
So the answer isn't actually an industry specific. Sorry, there isn't an industry specific answer. The answer is actually going to depend a lot on the characteristics of your individual organization. So if you're in a healthcare insurance environment, then there are some features of, for example, Google Cloud that you might want to take advantage of, particularly its context dependent data access, or its I've forgotten the exact name of the feature. You'll have to excuse me on that. I've momentary brain loss. But there are some features of Google Cloud Platform that allow you to define really clear patterns, or at least really clear paths that data is allowed to move through, and control the context in which users are able to access that data. So you can say, yeah, sure, it's coming through a public service. Sure, you might have the right username and the right password, but oops, you're on the wrong machine, and so you're not able to access the data. So if that's the kind of situation, GCP is a really excellent choice. On the other hand, if you're looking for sort of transparent encryption across a range of services, and you don't care so much about features like context, then Azure or AWS will serve you really well.
All right, excellent. And we have time for just two more questions. This one's for Brent. What are some common architectural mistakes that organizations make while ingesting in external data sources?
The number one is not anticipating schema change. As soon as you don't have access, as soon as you don't have control over your data source, you need to assume that that data source is going to change. It's going to change at random, and you want to make sure that the infrastructure that you've got built behind it is robust enough to be able to accept that change without sort of crashing downstream production processes. And the solution is pretty simple, and it's all about defining some domains in which the various parts of your ETL process are going to operate, and be really clear that when you're landing and staging data, that's all that you're doing. When you're picking data up and processing it and converting its format, that's all you're doing. When you're modeling data, you're doing one thing and one thing only, and that is that you're picking up, you're doing all of your pre-processing, and you're modeling the data.
Excellent, thank you. And we have time for just one more question. All other questions you could send me via email, and this one is for Doug. Mr. Laney, you mentioned data marketplaces. Can you tell us a little bit more about those?
Right, I guess I sort of glossed over that, and in fact, they could be an eighth data source. Data marketplaces are platforms where organizations can share or sell data to others, or identify data that's being sold by others that might be valuable. So platforms like DAWEX, who we work with, DAWEX, establishes these platforms and all of the transactional components that are required. They can share sample data and so forth. So there are a number of platforms out there for sharing or exchanging data. They can also be used internally as well. So companies that want to create an internal data marketplace can white label these platforms. But I guess they're sort of like data brokers, but they're more connecting buyers and sellers of data directly.
All right, excellent. Thank you both. Those were two excellent presentations. And as soon as the webinar will be processed, I'll send it out to the email address everyone provided. Thank you all, and tune in to the next time.